Okay, so here we are. I'm doing the questions from exercise 3.2 from the IBID textbook, and this is on page 82. So for question 1, we have the internal energy of a substance is equal to, and this is a straight definition problem. It's the potential and the kinetic energy of the molecules in the substance. We have the potential energy. This is from the bonds, from the chemical bonds. That's your potential energy, and your kinetic energy, that's from the movement. So the speed of movement of the molecules or the atoms within it is your kinetic energy. So that's your kinetic energy. Okay, the second question. The number of moles of sodium chloride NaCl in 100 grams of pure sodium chloride is. Now you are told here this big M. This big M is your what we call your molar mass, and that is the mass of 1 mole of that substance, and it is 58.5 grams per mole. So we've got in this case we've got 100 grams. So the formula we're going to use, the number of moles is equal to the mass of the substance that you've got divided by the molar mass. So it would be 100 grams divided by 58.5 grams, and it will probably equal to this one. I mean, this is the only one then anywhere in that sort of range. It will be about 1.71. So we've got question 3. There's something wrong with that question, so we'll leave that. And then going into question 4, we have a sealed flask contains 16 grams of oxygen, and it's got a mass number. Now this mass number of 16 is actually telling you the molar mass of oxygen. Now when we write the molar mass of oxygen of O would be therefore 16 grams per mole. We use this format of these square brackets like this to denote the molar mass. And we've got 8 grams of hydrogen. It's got a mass number of 1. So the molar mass of a single hydrogen atom is equal to 1 gram per mole. Now obviously if we've got 16 grams of oxygen and it's 16 is the molar mass, we've actually got the number of moles of oxygen of O. We've actually got 1 mole, and for hydrogen, because we've got 8 grams and the molar mass is 1 gram, we've actually got 8 mole. So it's going to be B. Question B. Looking at 5, the number of molecules present in 0.5 moles of SO3. Now we know that 1 mole, in 1 mole, it would correspond to 6.02 times 10 to the 23 molecules. So 0.5 mole would obviously equal half that amount, so it would be 3 times 10 to the 23. So we'd be looking at A. Fine, moving on to 6. Now we're looking at the number of atoms present. Now we've got SO3. Now, so in SO3, we're going to have 1 sulfur atom, and we've got 3 oxygen. So we've actually got 4 atoms. There are 4 atoms. So if we've got 0.5 moles, that's equal to, as we saw, 3 times 10 to the 23 molecules of SO3. In each molecule there's 4 atoms, so we'd have to multiply that by 4. You would get your 12 times 10 to the 23. So that would be C. Now here in the next one, we've actually been asked to calculate. Now I'm not going to do all of these. Firstly, I haven't got a periodic table with me now, and I've forgotten some of these numbers. Haven't taught chemistry in a while, but let's just do these 2 over here. Let's just do C and D. I think I remember some I remember the most of them. So calculate the approximate molar masses of each of the following. Now for each of them, when you look at the periodic table, you'll get a copper, for instance, and the copper, I think it's 64. I may be wrong, it will work as 64, it may be wrong. That number at the top is your molar mass. So the molar mass of copper sulfate is equal to, you first got your copper, which is 64, plus the sulfur, it's 32, plus your oxygen. Now each oxygen is 16, so we're going to have to times that by 4. So that is all going to be, and it's grams per mole. So we just got to add that all together. 16 times 4 is equal to 64 plus 64 is 128, 130, 160 grams per mole. It means if we've got a 160 grams of copper sulfate, we will have 6.023 times 10 to the 23 copper sulfate combinations. Your molar mass of Na2CO3 would be the same thing. We would get you got your sodium, that's 23 times 2, plus the C here is carbon, that's 12, and then you've got O3, that's going to be 16 times 3 grams per mole. So it's going to be, this is 46 plus 12 is 58 plus 48, so we're going to get 58, 64, 104 grams per mole. Okay, I hope that makes sense. Then calculate the amount of substance, number of moles in 100 grams of copper and so forth. Now I'm not going to do them all. Let's do this one over here, the calcium carbonate. Now to do this, we actually need to work out the molar mass. So we've got to work out the molar mass of calcium carbonate. Now calcium is 40, if I remember correctly, plus 12, plus O3 is 16 times 3, that's 48. So that's going to be 60, that's equal to 100 grams per mole. Then we just work that out just over here. Oh no, that was 104. Okay, and we've got 100 grams of it. So the number of moles is equal to your mass that you've got divided by your molar mass. So it's equal to 100 divided by 100. So you've got 1 mole. That's pretty straightforward, isn't it? 4.4 grams of carbon dioxide. Let's just do that one. Your molar mass of carbon dioxide is CO2, is carbon dioxide, is going to be C is 12 plus O2 is 32. That's 2 times 16 grams per mole, and so that's going to be 44 grams per mole. So we have got here the number of moles will therefore equal 44. Sorry, we're going to do, let's just rub that out. We are told we had 4.4 grams of it, sorry, divided by 44, so we've got 0.1 mole of carbon dioxide. Looking at number 10, let me just erase some of this because we're running out of space here. Hopefully you got all of that. You can always just rewind it or go back if you want. So going here, we have a sample of aluminium sulfate, has a mass of 34.2 grams. Calculate the number of aluminium 3 plus ions. Now basically we've got to work out the number of moles of this. Now to do that we need to work out the molar mass of aluminium 2 sulfate. Like that. Now I've actually forgotten what the what the atomic mass number for aluminium is. So that's a bit difficult. Let's just say it's I'll take a guess on it and say it's 46. You can check it out and change by numbers. So basically we're going to have to, it's going to be, let's say it's 46 times 2. I'm just taking a guess. For some reason I think 46 is correct. They've actually got 2 aluminium atoms. You see this little 2 it contains this 3 over here. This 3 over here on the outside here, basically telling you you've got 3 of the sulfate or SO4. So you've actually got 3 S's, 3 sulfate, and you've actually got 12 oxygens here. So it's going to be plus sulfur. Sulfur is 32 if I remember correctly, so that's 32 times 3, that's going to be 96. Plus oxygen is 16, and you actually got 12 oxygens. So you're going to have 16 times 12, which is 64 plus 144. It's going to be 208 if I've got that right. 208. You better check my calculations here. Grams per mole. And that total, well, let me use a calculator here. My brain is coming to an end with this. So it's 40, let me just put this on. 46 times 2 plus 96 plus 208, and I get 396. It's 390. Oh, sorry, I pushed the wrong button there. 396 grams per mole. Now you're actually told that you got 34.2. So the number of moles will equal 34.2 divided by the 396. So I say 34.2 divided by answer, and I get number of moles equal to 0.086. Now remember, there could be a mistake with this aluminium. I may have made a mistake with that number there. And so the number of aluminium ions is going to be, there's the number of moles of this whole substance is that. So aluminium ions is actually 2. So number of moles for the aluminium 3 plus would actually equal 0.086 times by 2. So I times that by 2, and I get 0.17. And the number of sulfate ions, the number of moles of sulfate ions, 2 minus, sorry, that is going to be 0.086, and we see that there's 3 of them for every molecule, so I times it by 3, so 0.086 times by 3, and I'll get about 0.258 mole. Alright, good. So hopefully if you need any further help on that, please come and talk to me. Classify the following as macroscopic or microscopic. Volume would be macroscopic. This would be macroscopic, so I'll use a big M for macroscopic. The kinetic energy of a particle, that would be microscopic. Pressure, macroscopic. Temperature, macroscopic. Alright, so I hope that helps. As I said, any need for it, please contact me if you need further help. Thank you very much.